Hi y'all. So today what I want to do is I want to look at the onion root tip cell mitosis lab. All right, now some of you actually got to do this in class, but most of you didn't actually get to the point where you could carry out the lab. So I'm going to do a quick summary of what we did in the lab or what we had hoped to do, but the main focus here is being able to do the data analysis. The main hope here is to do the data analysis for the lab. All right, so here we go. You see right here, it's got the objectives. The whole purpose is to better understand the process and stages of meiosis, and we want to be able to look at mitotic index and see which parts of the onion root are have a higher mitotic index than others. Now, we've talked about mitotic index in conjunction with cancer, that a higher mitotic index could indicate cancer, but that's for a specific type of tissue or a specific part of an organism. Here we're looking at 4 different parts of the onion root tip and recognizing that each of those different parts will be doing something different, and so we expect it to have a different mitotic index. Here, let me show you. If you look at the second page of the lab, there's some information here about the onion root tip. And what you can see is that you have one section that's kind of the tip of the root, that's the very, very tip down here, and that's what we'll call region A. Now, you don't need to know these specific regions. You just have to be able to look at this and recognize that there's different areas where we expect different things to be happening. So just right there at the tip, you have what we call the cap. We have then a second region right here right below the cap, and you can see that there's a whole lot of little itty bitty cells there. Now the reason why is because there's a lot of division happening. So the cell grows and divides and it divides and it divides, so we expect a very high rate of cellular division there, right? And then we have here in the middle, now this we say the middle, but remember this is still on the very tip of the root. Right here, we have a section where the cells are growing, right? They're duplicating, we're getting more and more down here near the bottom, but here, they're just growing, they're getting longer, that's region C. Now, as they get longer, again, they are going to divide. Now, part of the reason why they need to divide is because they're creating these extra root hairs and because it is creating then the actual length of the onion root. All right, so we do kind of have these 1, 2, 3, 4 different areas that we're hoping to see something different happening in. All right, so we'll move on. The next part of the lab is just to kind of remind you what the different phases of mitosis look like. So this is some real data here. This is just to kind of remind you what each of those is, but we will actually see later that when we actually do the lab, it's sometimes quite difficult to determine between those. That's one of the reasons why we're more interested here in the data analysis, because with the equipment that we have, it is very, very difficult sometimes to tell the difference between some of those different phases. All right, so here is the procedure. The procedure is just to kind of set up the lab to process the root in such a way that we can hopefully visualize which cells are undergoing mitosis and which ones are not. So now, this is where you would have collected your data, but what we've done for you is we've actually compiled a group of data, okay? And this data right here is from 15 different students. Now, these 15 students gathered a variety of different amounts of data in each region. So for example, student A, they went through region A, which was just the very, very tip there, and they counted how many cells were in Interphase, Prophase, Metaphase, Anaphase, and Telophase. Now you can tell there's not a lot of cells there. So they were probably zoomed in very, very far. They probably had a very high magnification, so they couldn't see very many cells at that time. But what we see is that there are other students who maybe had a much larger kind of zoomed out perspective there. And if that's the case, then you may see more cells, like student G here, who counted 120 in root A and 120 in Interphase and 10 in Prophase. And so different students gathered different data from kind of different perspectives, and that's fine. All of this is going to come together, though some of those big ones are going to affect our data a little bit more than some of the small ones. That's something to maybe keep in mind as you do your analysis later. Okay, they did the same thing for region B. They found some cells that were kind of right below or above, I guess, that root tip, where we expect some of that duplication to be happening. And then they did region C and then region D. And so they just gathered interphase, prophase, metaphase, anaphase, and telophase / cytokinesis there. We kind of grouped those together. I'm not sure why this one didn't have that, but I guess we can just add that, and that should be both there. All right. So now our goal as we go through the lab here, in part D, what it wants us to do is recognize that in an onion root tip, it takes about 24 hours to go through the mitotic cycle. Now, in that 24 hours, it should go through interphase, prophase, metaphase, anaphase, and telophase. So what we want to do is we want to find out about how much time. Now, we did this in class, but we did it with drawings. That wasn't real data. So this one, actually, we're taking some real data, and we're going to find out how much time it takes. For this one, what it actually wants us to do is it wants us to consider all of the interphase. So we're going to consider all the regions at once and find out how much interphase there is. And then it wants to do all of the prophase. Okay? Now, this is exactly what we did in class. We just didn't have this much data. So I'm going to talk you through how I would do this. All right? Now, I know how to use a spreadsheet. But to facilitate this for you so you can follow along, I'm not going to use any equations or anything in the spreadsheet other than showing you how I can add them together fairly quickly. All right. So what I want to do is I'm going to create a table right down below here that does interphase, prophase, metaphase, anaphase, and telophase / cytokinesis for each of the regions. So you'll notice that my first region A has interphase first, so the interphase is 888. The prophase is 329. The next one is 52, 37, and 39. So that is all of the data. That's all of the data from region A. So now I'm going to do the same thing for region B, C, and D. So region B, I can see is 1034, 493, 97, 74, and 90. Then we'll move on to region C. So 641, 380, 40, 40, and 44. All right. And then we will move over to region D, where I can see 391, 167, 18, 19, and 18, 10, and 21. So I need to change that to 10 and 21. So I've got all the data in. All right. So these red numbers are the sum of all of the students that did the data. So in this part D, it is actually asking us to do all of the data for all of the phases in each cycle. So what I want to do is I want to find out how many total are there in interphase. So you could actually type this into your calculator. Okay, you'll notice in my spreadsheet that if I highlight all those, it'll automatically give me the sum. You can type in a formula here as well, but I'm just going to do this because I think it'll be easier for you to follow along. So 2,954. All right, and then I'll do the same thing for prophase, metaphase, anaphase, telophase. So I'm adding up all of the interphase from all 4 regions. Okay, then I'm doing all of the prophase from all 4 regions. This is what it's asking us to do in that first section there. All right, so I'm going to go ahead and do that. You can follow along. So I've got my prophase, which adds up to 1,369. I've got my metaphase, which adds up to 207. My anaphase, 161. And my telophase, 194. All right, so now I've added them all together. Now, you'll notice here it actually added all of those together for me automatically. I did set that up. But if I highlight, what you'll see if I highlight all of those, if I add them together, if I did that on my calculator right here, you'll see 4885, which is exactly what it has there. Now, to find the percent, I want to find out what percent of these are in interphase. So remember to do that. I'm going to take the interphase, the number in interphase. I'm going to divide by the total number, and then I'll multiply by 100. So I'm actually just going to type that in here. Okay, so in that cell, I'm going to type in equals 2954 divided by 4885, and then I'm going to multiply by 100, and it gives me 60%. So 60% of these cells are in interphase. I can do the same thing for prophase, metaphase, anaphase, telophase. I'm going to just type in the same thing. So I'm going to go through that right now. You can follow along if you would like. So for prophase, I'm going to type in 1369. Sorry, I need to go equals 1369 divided by 4885 and times 100. And I know somebody's saying, Mr. Bauer, there's an easy way to do that on the spreadsheet. I know there's an easier way to do it, but I want to make sure that anybody watching understands what I'm doing here. So no special spreadsheet stuff. I'll teach a spreadsheet another day. 207 divided by 4885 times 100. And 4% there for the metaphase. And then I'll do anaphase. So equals 161 divided by 4885 times 100. And the telophase, 194 divided by 4885 times 100. And I get 4. Now, ideally, those percents should add up to 100, right? So if I highlight all of those, look at that. My sum is 100%. How about that? It should. Your percent should always add up to 100. That's how percents work, is that everything is 100%. So therefore, I get 100% there. All right. Now, the last step is then to calculate the time. Now, remember, to get the time, we're going to take the percent. We're going to turn it back into a decimal. So I'm going to take the percent divided by 100. And then I'm going to multiply by the amount of time that it takes to do a full cycle, which for an onion root tip cell is 24 hours. Okay? So for the interphase, I'm going to take that 60%, okay, divide it by 100, and then multiply it by 24, and I get 14.4 hours. I can do the same thing for prophase, 28%, so that's 28 over 100, multiply by 24, so 6.7 hours. You can see that there's more than twice as many in interphase, right? 60% are in interphase, 28% are in prophase, so more than twice as many are in interphase. So I expect that it should be spending more than twice as much time in interphase. I got 14.4 versus 6.7. That's a little more than double. All right, so I should then be able to go through and answer the rest of these. Note that I am doing this based off my spreadsheet automatically rounded my percent to a whole number. If you use the actual values, you might get something slightly different here. I'm just going to use the 4 divided by 100 times 24, the 3 divided by 100 times 24, and the 4 divided by 100 times 24. Yep, I do need an equal sign there. All right, so at that point, I do get a total of 23.8. That's because there's some rounding that went on there, so my numbers are slightly off, but it does more or less add up to 24 hours. So therefore, I've done part D now, right? Now, actually, in part D, the other thing that it wants us to do is it wants us to create an appropriately titled and labeled graph that it displays the time of a 24-hour cycle for each stage. So therefore, I do need to present this data in a graph. Now, then we kind of have to decide what kind of graph do we want to use. Now, a line graph or a scatter plot wouldn't really make sense here, right? A scatter plot is valuable when you're comparing one value to another value, like time is progressing, or we're changing the mass, and that affects the speed or the height or something like that, right? You have two values that you're comparing how this one is changing that one. That's not really what's happening here. Here we have these different categories. We have the interphase, the prophase, metaphase, anaphase, telophase, and each one of those has a specific value, right? And so that will be much better demonstrated using a different type of graph. Now, you could use a bar graph, right? You could just have one bar that shows the time for interphase, one bar that shows for prophase, one bar that shows for metaphase, and you could see how long those bars are. Now that would probably be okay, but it's probably not the best. The reason why is because we do have a total here, right? We know that the total should be 24 hours. Now, because we have a total, then it might actually be better to show a type of graph that represents the total that's then divided into individual pieces so that you can see those individual pieces add up to give the whole. And you notice that as I'm talking about pieces and the whole, I am kind of demonstrating a circle here. So what I'm actually going to do is I'm going to ask it to do a pie graph for me, all right? So I'm going to take my interphase, prophase, metaphase, anaphase, telophase. I'm going to highlight those. And then I'm also going to highlight these 5 right here. And I'm going to go Insert, Chart. And I'm going to tell it that I would really kind of like a pie chart. All right? Now, when I do this, you'll notice that it does. It actually takes my data and says, well, this is the total amount of time. I guess I need to make this a little bit bigger so you can see the whole thing. All right, there we go. And you can see there that it's labeled. Okay, I probably do need to change the label on my graph here. So I'm going to say time spent in each phase of the cell cycle. All right, and we're going to close that. And so now you can see that interphase is 60.6%, which is a good percentage there, right? We've got the prophase, which is here, the telophase, the anaphase, the metaphase. You can see each piece and how that is connected to the whole. All right. Now, one of the things I do notice is that it's giving me the percents instead of the hours, and I really wanted it to be in hours. So I'm going to go in here to pie chart, and I'm going to say I want the slice label to be the value because I actually want to see that value there. And then I think that's probably okay. I don't know that I need to change anything else. So that then gives me a graph, and I can see 14.4 hours, 6.7 hours, 1.0 hours. This one isn't quite showing up there, but if I click on it, the 0.7 hours if I click on it. All right. So we've done part D. We found the time spent in each cycle. We've made an appropriate graph that best describes this. Now, this is where you're going to have to make some decisions based off of the data given to you. Is it best to use a circle graph? Is it best to use a scatter plot? Or is it best to use a bar graph? Line graphs are probably out. Shouldn't really ever choose a line graph because it does weird stuff. All right. So we're going to move on to part E here. Okay, in part E, it wants us to calculate the mitotic index, and it's going to have us do the mitotic index for each of the regions. Okay, so I'm going to go back to the data, and I am going to do the mitotic index by doing the number of cells in mitosis divided by the total number of cells. Okay, and so I'm going to move my graph out of the way here. And so now I'm doing mitotic index down here. You'll notice that I've already taken the interphase from A, B, C, and D, and I've copied those down here. And so now I'm going to put the total number that are actually going through mitosis. So remember, mitosis is prophase, metaphase, anaphase, and telophase. So if I add all those up for A, you'll see it gives me a sum of 457. So I'm going to go 457. I'm going to do the same thing then for region B, region C, and region D. And when I add each of those up, just the prophase, metaphase, anaphase, telophase, that will tell me how many of the cells are participating in mitosis. Because remember, mitotic index is what portion of the cells are undergoing mitosis at any point in time. So that's what we're going to look for here. So B is a total of 754. C is a total of 504. And then D is 216. All right. So now I know how many total cells there were in I know how many there were in interphase. I know how many there were in mitosis, and of course I also know the total number of cells. I could get the total number of cells for each region just by highlighting that section there. Okay. So the mitotic index here That's my last step. That's the last thing it wants me to find. And so for the mitotic index, what you want to do is you want to take the number of cells that are in mitosis and divide by the total number of cells. Okay, so the way that I'm going to do that is I'm going to type equals the number of cells in mitosis, which is 457, and then I'm going to divide by, now I'm going to put parentheses here because I want to divide by 457 plus 888, right? Because that would be the total number of cells there. And so it gives me a mitotic index of 0.34. I can go and do that for each of the regions. So for region B, I'm going to go equals 754. That's the number of cells in mitosis, divided by the total number, which is 1034 plus 754. So add up all of them there. We've got that. We can move on to C. 504 divided by 641 plus 504. Just like that. I get 44.44, and then I can go into my last region, region D, and I go equals 216, which is mitosis, divided by 216 plus 391. That'll give me the total there, and I get 0.36. And so in the end, I can now analyze my data. I can see that there are definitely a couple of regions, right? B and C looks like there's a fairly high mitotic index of 0.42, 0.44. And then A and D are a little bit lower, that there's a little bit less mitosis going on there. Now we can talk about that and why there is mitosis and why we think that's the case. But for now, my goal for this video is just to then talk to you about how to do these calculations and make sure you're comfortable with it. Okay, now at this point, if you are finishing the lab, you should then go through and you should answer each of the questions, right? There's 3 questions left there. Go through and see if you can answer those. You can always message me if you have any questions about it, and I'm happy to help answer any questions that you might have. So you can go through and do that. The other thing, if you are in my class and you're taking an assessment next time, please make sure that you have a look at ManageBack, look at the other details, the other tips that I've listed there, because those are also things that might be valuable for you to know before I see you for the assessment next class. All right, so I hope that video was helpful, whether you're in my class or not, and we will see you next time.